Okay, I hope I'm audible to all students who are attending this practice lecture for Intermediate Microeconomics Part 1. In this particular practice lecture, we continue with our discussion of the back problems from Chapter 2 of a short course in Intermediate Microeconomics by Serrano and Feldman. Okay, so we look at the back problems. We have discussed in the previous lecture, starting from problem number 1, we have discussed till problem number 4 in the previous lecture. And this chapter 2 of Serrano and Feldman is based on concepts of preferences, consumer preferences, and utility functions. Okay, now in today's lecture, I'm going to wind up with the back problems for chapter 2 by looking at problem 5 as well as problem 6 in today's lecture. These are the last two problems in chapter 2 of Serrano and Feldman. So let's look at problem number 5. Donald likes fishing. Fishing is X1 and hanging out in his hammock. This is X2. So there are two goods, X1, X2. The utility function is given by 3x1 square x2 to the power 4. Okay. So if you plot the indifference curves, these are going to be convex indifference curves for Donald. Okay. Where averages are preferred over the extreme bundles. Okay. The first part asks us calculate the marginal utility of fishing. Okay, so let me quickly come to the whiteboard and let's solve this problem in depth. I'm writing the main heading for completeness. This is worked out problems. Worked out problems, chapter 2. A short course in intermediate microeconomics by Serrano and Feldman. Okay, so in this lecture, we are looking at our discussion of problem number 5. We are given that there are two commodities or goods or whatever you want to say. One is fishing, call it as good X1, and another is hanging out in the hammock, good X2. The utility function is given by 3x1 square x2 to the power 4. Okay, part A asks us find marginal utility from fishing. Fishing is good X1. mu1, how do we find that? The partial derivative of the utility function with respect to X1 gives you the marginal utility from fishing. This is mu1. Now let's partially differentiate the utility function with respect to X1. What do I get? The derivative of X1 square is 2x1. And when you are partially differentiating with respect to X1, X2 is a constant. So X2 to the power 4 is as it is. The marginal utility from fishing is 6x1 x2 to the power 4. 6x1 x2 to the power 4. Okay, let's look at part B. So let me come to the back problems. Calculate mu2, which is the marginal utility of hanging out in his hand. Very simple. Let's quickly calculate mu2. That's the partial derivative of the utility function with respect to x2. How do I find that? It's 3 times. Now, when you are partially differentiating with respect to x2, you're keeping x1 constant. So 3x1 square. The derivative of x2 to the power 4 is 4x2 cubed. The answer is 12 x1 square x2 cubed. That's my marginal utility from hanging out on the hammock. Part C. If I come back to the back problems, calculate MRS. This is the rate at which he is willing to substitute hanging out on hammock for fishing. We all know the formula for MRS. In absolute terms, absolute means I take the modulus, I ignore the negative sign. In absolute terms, MRS is just mu1 by mu. What is mu1? 6, x1, x2, 4. What is mu2? 12, x1 squared, x2 cube. What do I get? If I solve, I get 1 over 2 times x2 over x1. Half times x2 by x1. This is my absolute value of the MRS. Okay, then let's look at the next part to this particular problem. Last week, Donald fished 2 hours a day and hung out in his hammock 4 hours a day. Using your formula for MRS from part C, find the MRS last week. So we have to just put in the values of x1 and x2. So in part D, we are given that Donald fished 2 hours a day. That means x1 is equal to 2 and hung out on his hammock 4 hours a day. That means x2 is equal to 4. And this was last week. So what is my absolute value of the MRS at x1 equal to 2 and x2 equal to 4? So in the general equation of MRS, just put x2 as 4 and x1 as 2. So I get my answer as 4 by 4, which is 1. This is my MRS. This is the MRS of Donald last week. Okay, and then let's look at part E. So if I come back to the back problems, this week Donald is fishing 8 hours a day and hanging out in his hammock 2 hours a day. Now calculate his MRS this week. Has the MRS increased or decreased? Explain why. So now let's come to the whiteboard and solve this part. For this, I am erasing now the initial parts. I hope all students have understood the solutions to parts A and B, so I am erasing them off. Let's look at part E. In part E, we are given that now we are given the data about this week. Donald is fishing 8 hours a day. So x1 is 8 and hanging out in his hammock 2 hours a day. So x2 is 2. Okay, this is the data for this week. Can I quickly find the absolute value of the MRS? Half times x2 by x1. x2 now is 2, x1 is 8. My MRS this week is 1 by 8. What do we see? We see that the MRS has gone down. Last week it was 1, now it's 1 by 8. You can see last week he was just fishing 2 hours and hanging out on his hammock for 4 hours. Now he is moving along the x-axis. So he is now fishing for 8 hours instead of 2. And now he is riding or hanging out on his hammock only for 2 hours. That means he is moving down the indifference curve. If I show this in pictures to our students, let me erase the initial part now. We all know the topic and the question we are doing. So if I draw a diagram to depict this, students can look at this diagram. This is x1, which is fish catching the fish. This is fishing. And x2 is hanging on the hammock. Hanging out on hammock. If you look at the utility function, it looks very similar to Cobb-Douglas. It's a convex indifference curve. Okay, so last week on this indifference curve, the bundle was 2 and 4. That means x1 was 2 and x2 was 4. And the MRS in this case was coming out as 1 in absolute terms. This was last week. This week, you have 8 and so this is 8 and think of this as 8, 2. Now 8 hours of fishing and 2 hours of hanging out on the hammock. Here the MRS is coming out as 1/8. See? Remember the properties of indifference curves? MRS diminishes as you move down the indifference curve from left to right. So I can say that the MRS has diminished from the last week to this week. MRS has diminished from the last week to this week because Donald has moved down his indifference curve. Donald has moved down his indifference curve. And I can further elaborate by saying that if I erase this part off, I can further elaborate by saying that as this is in continuation of the explanation, as Donald spends more time in fishing and less time in his hammock, he is lesser and lesser willing to give up hammock time for an extra hour of fishing. For an extra hour of fishing. I have done all this in the properties of indifference curves. Why does MRS diminish, guys? MRS is diminishing because for every unit of good X, 1, the consumer is lesser and lesser willing to sacrifice good X2. Because when you start losing X2, it starts becoming more important to you. As a result, you are lesser and lesser willing to give up now to buy one more unit of X1. Same thing is happening with Donald also. When he moves from 2,4 to 8,2, he is moving towards more hours on fishing. So now he is lesser and lesser willing to give up his time on hammock because a consumer always wants more of both the goods. When you are devoting more time to fishing, you have to give up some hammock time, but now you are lesser and lesser willing to give that up because it grows in importance to you when you start losing it. When you start losing your time on hammock, it becomes more important to you. So now you are lesser and lesser willing to give that in exchange for an extra hour on fishing. Okay. So I hope that students have understood the complete explanation for part E. Okay. This was part E. So we are done with part E and part F. If I come back to the back problems, what is part F asking us? Is Donald happier or sadder this week compared to the last week? He is equally happy because he is still on the same indifference curve. So you see, this is this point corresponds to this week and this point corresponds to last week. Both the points lie on the same indifference curve. That means Donald is equally happy. So I can erase this particular part. I can erase this particular part and I can write that since 2,4 and 8,2 lie on the same indifference curve, since they lie on the same indifference curve, I can say that Donald is equally happy this week and last week. Now, students must be thinking, how can you say that 2,4 and 8,2 lie on the same indifference? Put them in the utility function. What is my utility function? U of x1, x2 is 3x1 square, x2, 4. Calculate u of 2, 4. it's going to be 3 times 2 square. 3 times 2 square times 4 to the power 4. Okay, which I can also write as 3 times 2 square. 4 I can write as 2 square. So this I can basically write as 2 to the power 8. And this is 3 times 2 to the power 10. I'm using the power rules basically. Okay, and similarly my utility from 8 comma 2 will be 3 times 8 square times 2 to the power 4. 8 I can write as 2 cube, and 2 cube squared up is 2 to the power 6 times 2 to the power 4. All power rules I'm using, which we have learned in the basic mathematical methods for economics course. This is again 3 times 2 to the power 10. So both are equal. Utility from 2 comma 4 is exactly equal to utility from 8 comma 2. Therefore, the bundle 2 comma 4 and 8 comma 2 lies on the same indifference curve. That means that as far as Donald is concerned, for him 2 comma 4 and 8 comma 2 are giving him equal amount of happiness because they both lie on the same indifference. So the answer for point F is that Donald is equally happy. He is neither sad nor happy. He is equally happy this week and last week because both the bundles lie on the same indifference. Okay, so with this we are done with problem number 5 for discussion. Let's come to problem number 6. Suppose you are choosing between hours of work, a bad measured on the horizontal axis, and money, a good measured on the vertical axis. Okay, so explain the meaning of MRS in words. Okay, so first of all, let me come to the whiteboard and let's take this up for discussion. So we are looking at problem number 6. We have two commodities. We have two commodities. One is hours of work. Hours of work, which is a bag measured on the horizontal axis. Hours of work, which is a bag measured on the horizontal axis. And we have money, which is a good measured on the vertical axis. A good measured on the vertical axis. Okay, so if I plot a diagram, we have hours of work here, which is measured on the horizontal axis as given in the question. It's a bad. Consuming more of it gives you disutility or dissatisfaction. On the vertical axis, we have money, which is a good. Now remember from my lectures on consumer preference and utility, how does the indifference curve look like when you have a good, bad on the horizontal and good on the vertical axis? Your indifference curves are upward sloping and they are convex. Because your direction of preference is north-west. Higher indifference curves are in the northwest direction because you want to reduce your bad and increase your good. If you are going in the northwest direction, you are reducing your bad, increasing your good, which increases your utility. So my indifference curves are going to look like this. If I draw a family of indifference curves, erasing this off, if I draw a family of indifference curve, it's going to look like this. This is one indifference curve. This is another. IC1, this is another indifference curve, IC2, and so on. So I can say that the indifference curves are upward sloping. The indifference curves are upward sloping, and higher indifference curves are in the northwest direction. Higher indifference curves are in the northwest direction. Now let's interpret the MRS. Okay, MRS is what? MRS is nothing but change in Y by change in X. On the Y axis, we are measuring money, so change in money. On the X axis, we are measuring hours of work, so change in the hours of work. So what can I say? I can say that MRS measures the amount of money. MRS measures the amount of money the consumer is willing to give up, amount of money which the consumer is willing to give up for an extra hour of work. For an extra hour of work. Okay. And now if you look at the MRS in this case, will it be positive or will it be negative? So first of all, I have explained part A. Now, will MRS be positive or will MRS be negative? So I can say that in this case, MRS is going to be, my slope of the indifference curve is actually going to be positive. The slope of the indifference curve is actually going to be positive, which implies that my indifference curves are going to be upward sloping. Okay, so I can say that if I, so this is my answer for part A, question 6, part A. Okay, if I look at part B, if I look at part B, what is part B asking us? So if I come back to the, should MRS be positive or negative in this case? Now guys, when I draw a downward sloping indifference curve, I take the MRS as negative. For a downward sloping MRS, for a downward sloping indifference curve, MRS is negative. It's negative mu1 by mu2. So for an upward sloping indifference curve, MRS will be positive. So if I come back to the whiteboard, I can say that for a downward sloping indifference curve, MRS has a negative sign. For a downward sloping indifference curve, MRS has a negative sign. Okay. Therefore, for an upward sloping indifference curve, MRS is positive, which indicates that someone will have to pay me more money to have me work more. If MRS is negative, it means I have to give up money to work more. But if MRS is positive, as in this case, indifference curves are upward sloping, MRS is positive, it indicates instead of sacrificing money, someone will now have to pay me money. Only if someone pays me more money, I will be willing to work more. That is how you interpret a positive MRS. If MRS was negative, it would have simply meant that I have to sacrifice money to work more. But since MRS is positive here, because working is a bad for me, since MRS is positive here, it simply means that instead of me sacrificing money, someone has to pay me more money in order for me to work more. Okay, so And I think this is the answer for part C also. Part C is nothing but the diagram. If you look at part C, let me come back to the back problems. Is your MRS increasing, constant, or decreasing as you increase the hours of work along an indifference curve? Explain and draw some indifference curves. We have already drawn the indifference curves. Okay. Now, if I increase the hours of work, what is happening to MRS? So I can say in this case, MRS is increasing. So MRS is, instead of diminishing, which happens in a downward sloping indifference curve, in this case, MRS is increasing as the hours of work increase. This is my answer for part C, and this is the diagram for part C. MRS is increasing as the hours of work increase. Hence, the indifference curves are upward, sloping, and convex. The indifference curves are upward sloping and convex. Okay, so with this, we are done with our discussion of problem number 6. Okay, and I hope that all students have understood and have enjoyed the lecture today. Okay, so we are still left with, I think, a few more problems, which I think we are still left with problems 7, 8, 9, and 10, which I plan to discuss in the coming lectures. Okay, so I hope all students have enjoyed this lecture. Okay, I'm just writing that in the next lecture, we are going to focus on problems 7, 8, 9, and 10. So I stop in this lecture. I hope all students have enjoyed this practice lecture. Any doubts? You can unmute your mics and ask, or you can call up or get in touch with me for doubts on WhatsApp, or you can mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.